This is going to be one of the tougher videos that we take a look at. Percentiles. First of all, let's talk about percentiles. The definition of a percentile is the percent of scores at or below a given score. So if you have a score that's at the 82nd percentile, in a normal distribution, what that tells me is that that score is out here someplace. And it has 82% of the distribution to the left. And 18% of the distribution to the right. Now, calculating a percentile ranking is very, very easy to do because really it's just the probability of below, right? The probability below. So if we have ACTs normally distributed with a mean of 20.6, 5.9 in a particular year, what is the percentile ranking for an ACT of 26? Well, guys, essentially this is saying what's the probability that we have an ACT less than or equal to 26. And we will know that from previous problems that finding that is very, very, very easy to find. So we would have the standard, we would have a mean of 20.6, standard deviation 5.9. We would have x less than or equal to 26, and we would compute. Now this gives the probability to compute to convert to a percentile. We just look at the wow, this is really crazy. This would actually be at the 82nd percentile. And I say it's kind of freaky because if you look, I gave this example of I had no idea. That is just that's just kind of crazy that it worked out that way. But guys, the answer will not always be the 82nd percentile. But my point is, the percentile ranking is always the probability of below. Now, let's get into some tougher questions. What we've done so far. So far, what I've attempted to teach you here is how to calculate probabilities, percentage, and percentile. So hopefully we can do that. Let's just take a look at some random problem here. Let's just bounce it back off of z-scores. What's the probability that we have a z less than or equal to 1.92? Well, if we're going to look at the probability problem, we're going to have mean 0, standard deviation 1 because it's a z-score, the standard normal distribution, less than or equal to what we've got, 1.92, and compute. So the probability is 0.9726. The percentage is 97.3%. And again, don't get caught up on rounding because, well, guys, sorry, you're not seeing what I want you to see. All right, better. Don't get caught up in rounding because my stat lab will tell you how they want to round it. So probability directly from the output, Percentage, just convert it to a percentage. Percentile, convert it to the whole number. So just depending on the way you're asked, the question is posed, do we want the probability of it? Do we want the percentage? Or do we want the percentile ranking? You still, I'm pointing over there to my stat lab, you still use that normal calculator that I've taught you so far. Now, let's change the game completely. What IQ represents the 80th percentile? Now, gang, what we got going on now is completely different. We're not asked to find a probability, a percentage, or a percentile. We are given the percentile, and we want to find the score that represents that. So in other words, guys, in the distribution of IQs, there is some IQ that has 80% of the IQs below it, and 20% of the IQs above it. But it turns out in working this problem, we can just kind of be very clever in the way that we manipulate the operation on stack crunch to give us exactly what we need. Now, how are we going to do that? First of all, we're going to go to standard. Make this a little larger. And I'm going to go to the mean. So remember, guys, IQ has a mean of 100. Standard deviation of 15. But now what I want is I want less than or equal. I want to leave this blank. And I want the area to the left. Remember, less than or equal to means to the left. I want the area to be 0.80. Now if I compute, it will find the IQ that has 80% of the distribution below it. So it has percentile of 80th percentile, or it has what? Probability of 0.8. So guys, the IQ would be 112.62. Now, let's take it a little bit further. This one drives students crazy all the time. IQs form a normal distribution, mean of 100, standard deviation of 15. Find the IQR. And students lose their minds when I give them this problem. And there's one of these on, there will be one of these on your My Stat Lab assignment too. Find the IQR. Now guys, remember from many moons ago, IQR is what? Q3 minus Q1, right? So how does that help us? Well, how it helps us is, let's think about what Q3 and Q1 actually represent, but let's do it in the form of a normal distribution. What percentage of scores is below Q1? 25%. What percentage of scores is below Q3? 75%. Can I find the number from this distribution that has 25% below it? Well, absolutely I can. I got it right over here. Mean of 100, standard deviation of 15. I need less than because I'm pointing to the left. I want this to be blank, but I want this to be 0.25. So I know Q1 has to be 89.88. Now, what does Q3 have to be? Well, Q3 has to be 75% below. So Q3 has to be 110.12. How do I find the IQR? Subtract. So the IQR is going to be 110.12 minus 89.88. Guys, I'm going to use my calculator here because I don't want to think that hard. So 20.24. Now, notice that we have two measures of spread, the IQR and the standard deviation. Notice that the IQR is larger. That's kind of to be expected. Now, is there a different way we could have done this? Well, I don't know. Let's investigate it. Let's go to between. Got the mean and standard deviation. I want to leave that blank. I want to leave that blank. And I want to come in here and put what? Well, by drawing over here, what's the area between these two right here? 50%. Guys, that's the definition of the IQR, right? It's the range of the middle 50% of the data. So if I just come in and put 0.50 here, do you think that's going to work? Sure does. Finds the middle 50%, doesn't it? Just by putting the 0.5 there. So I can use the between in one step, or I can use the standard in two steps like I did before. I think this is easier. Well, I don't think it is. I know it's easier. All right. A highly selective university accepts students with an SAT in the top 8%. What is the minimum SAT that's required for acceptance in this university? Use. Now we're looking at overall scores here, so I think that's about right. You know, I've actually got an SAT overall up. Let's see, SAT. I was thinking the standard deviation was higher. Yeah, I think the standard deviation is higher. Let's use 200. Actually, I see it right here. It's actually 193 for this particular year. Okay, so 1,086, 193. What is the top overall SAT? I should say, what's the bottom to be accepted in this university? Well, guys, this over here does it. So I'm going to use the standard. I'm going to use the mean of 1,086. We'll use the standard deviation of 193. I want above area to be 0.08. So guys, it's going to take a pretty big old whopping SAT. So it's going to take what, 1350, well, I might call it 1357. Technically, to get at 8% or higher, you'd have to have a 1358. But if you were given this on my stat lab, it would probably ask you to round to maybe 2 or 3 places. So depending on what it tells you to round appropriately. All right, gang. I don't know anything else to talk about here. I will look at one more type of question. This is another question that drives my students crazy from time to time. They absolutely lose their minds. I have no idea why. Z-score, you should think. Normal distribution means 0, standard deviation 1. 35th percentile says, now where should I draw my line? Should I draw it over here, over here? Well, guys, right in the middle is the 50th percentile, because it cuts the distribution in 2 equal pieces. So 50% of the scores are below. So I know the 35th percentile is going to be about right there someplace, with 35% of the scores below. And because I'm looking at z-scores that has a mean equal to 0, I know anything to the left is negative. So I know my answer must be negative something. Again, 50th percentile, 40th, 30th, 35th, anything to the left of the mean has to have a negative value. So let's do it. So what do? I have a mean of 0, standard deviation of 1. So I want P less than, and I want this to be 0.35. So the z-score is negative 0.39. Guys, done with this video. There'll be one more video I think I'll put up after this. What I'll do is I'll go in and pull out like 3 or 4 of my stat lab questions, and I'll work those for you. But other than that, we're about to wrap up this what I'm going to teach you on the normal model. So take care.